So today we're going to study similarities and a sequence of transformation. So not just one movement, it could be a series. But before that, let's review the four geometric transformations. We've learned that in translation, okay, these are preserved, yes, yes, yes. Only the location is changed. Same size, same shape. You know all of that. Now, in reflection, everything is a yes except for the orientation and the location. The orientation, remember, if there's flipping, all right, only that changes. Of course, location always changes. In rotation, we've learned that everything is a yes, everything is preserved except the location. It just turns around and goes somewhere else. But in dilation, we learned that there's a no here, the size that matters. They all look alike, but it's the size that goes bigger or smaller. So today we will focus on this. The translation, reflection, and rotation. Take note, it has a yes, 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 yes. Same size and shape means they are congruent. Congruent, right? So now we call this now rigid. When you say you're rigid, you don't change, right? Rigid, the same size or shape of the pre-image when producing the image. So it is preserved. Now, only in dilation where the shape preserved but the sizes changes, right? Because of that note over here, we call that now the non-rigid transformation. It's like the major change. The size changed, so it's not rigid anymore. Check out what you could do when you imported an image in PowerPoint, right? When you make projects, you get images from the web, you get images from the clip art, and then you adjust the image depending on how you want to design your PowerPoint. Let's watch this. Did you know that when you use your PowerPoint, you use graphics from the internet or from the clip art, you're already doing series of transformation. For example, this chicken image is a pre-image. The options that I could do is I could translate to the left. That's usually what we do, right? A single translation. But in real life, you do more than one transformation. Check this out. I could translate to the left, depending on the number of units. You'll count that, okay? And then I could do another transformation after that. I could reflect along the x-axis. See that? So now I made a series. Translate to the left, reflect along the x-axis. Okay, so that's what you call sequence or series of transformation. But you know, you could be creative. I could do another way of sequence of transformation. I could reflect along the x-axis and then dilate with a scale factor of 1/2. It got smaller. See that? That's another series. Now, it's for you to identify what transformation happened based on the characteristics. Again, the change of different size, shape, location, orientation. Let's try another one. Let me dilate first, okay? Then translate down, then reflect on the x-axis. That's what the figure is. Now, in the next lessons, you will have to identify what are the series of transformation. It's nice to play around with it, right? Okay, one last. Let's try one more. Okay, what other translation have we not used yet? Let's use a rotation, right? Let's use a rotation. That's a rotation from the middle, okay? The middle of the figure. Rotate clockwise 180, and then what did I do? I translate down. See, check out the rotation too. You might think that this is a flipping. No, that's not a flipping. Okay, because if that's a flipping, it's gonna look like this. That's a rotation. What's the difference? Okay, check this out. If you do a reflection, it will look like this. So you have to be careful with the rotation and the reflection. See that this is the exact reflection, but this generated through a rotation. Why is this a rotation? Because the orientation is preserved. Check this out. The orientation is preserved. Okay, let me turn this around. See that? The orientation is preserved. The finger is still there. But this one, if you turn this around, is the orientation preserved? Let's check it out. See? The orientation is not preserved anymore. Okay? This is still right, congruent, same size, same shape. But this one, it isn't. Okay? That was the product of reflection. Remember that reflection. See, there are series of transformation that you could do. One last. Let's do another one last. What else? Let's do a dilation. Smaller. Translate to the right. And then rotate 90-degree counterclockwise. See that? And then translate down. Again, it's for you to identify what series of transformation happened. Now, let's examine this series of transformation. Pre-image, that means it started there, obviously, right? So let's start by looking at this point, going to that point. Remember, compare the corresponding points, right? So let's move 1, 2, 3, 4, 5, 6. But don't stop there. 7, 8. So that 8 units to the left. Okay, so let's write it down. Translated 8 units to the left, but look at the image, the second series of transformation. This one, okay, is it still also sliding down? Check again. It's not sliding down. The figure was flipped. Therefore, if it's flipped, it is what? A reflection along the x-axis. This is the mirror. How do you check? 2 units away, 2 units away. Check that out. Okay, we're good. Number 2. Now let's describe this transformation. But first, let's look at the letters so we know where it began and where it ended. Now, check out the A. A, this is A prime, this is A double prime. So it means it started with the blue triangle, going to the pink triangle, and then to the brown triangle. Now, if you look at A to A prime, okay, did it simply slide? Look at the location, right? Did it simply slide? Yes, the A is still there, A. But here, B is on top, but suddenly, so if you slide, the B should still be on top. But check it out, the B is now below. So what happened? You observe that there is a flipping, all right? And to check if it's really a flipping, okay, check this out. 5 units from the X, 5 units from the X. 2 units, I mean 1 unit on top, 1 unit below. 3 units on top, 3 units below. So it is flipping. So our first translation, our first transformation rather, is a reflect along the x-axis. Now, from the pink, it went to the brown. Look at the orientation. Was there flipping? Or the orientation is preserved? Yes. You just move to the left. Okay, so let's see now, but how many units? Let's count. Count the number of units. Let's use A as our reference. 1, 2, 3, 4, 5. So therefore we could say translate 5 units to the left. Okay, good job. Next, describe the series of transformation. This XY is a new line. Normally, we reflect along the X or along the Y. Now, we can also reflect on the slanted line. You call that the Y equals X. Obviously, if you look at 1 and 2, right? Okay, is there a rotation? It yeah, it could be, right? But it can also be a what? Check this out. Check this out. It could be the unit. How many units is that? Are they preserved? Okay, this is preserved, preserved. So with what can you say? It's a reflection along the XY axis, right? Now, after reflecting, you would see that it went up there, right? But if it goes up, but it does not exactly follow a path. Let's check it out. 1, 2, 3, 4, 5 units, okay? This point should be up there, but now it doesn't match. Therefore, there could be more than 2 series. Translate 5 units, that should be up here, but suddenly that point went over here. What can you say? One more to the, okay, one more unit to the right. Now we're on the exact location. Next, describe the following. Think first. Okay, ready? Here we go. From 1, obviously I went up. Is that 0 units? Nuh-uh. Don't look at the space. Look at 1, 2. Corresponding points. So what can you say? 2 units up. And then what happened? There's a turning, right? So you know it's rotation. Is it clockwise or counterclockwise? Okay, check it out. It is what? It is clockwise by how many degrees? Correct. 90-degree clockwise. Or you could do the opposite, 270 counterclockwise. Next, from here to here, what can we say? We translate. You could do, no, two ways. You could go upright, or you could go upright. I just, we don't have coordinate planes here, so we cannot fully describe it. Or you could do upright, or you could do right up. It's either or. So basically, you just translate. Two translations, and then after two translation, look at the coordinates. These there, same units, okay? What do you call that? Far away from that line, it's a reflect along the y-axis. All right. Next. Wow. So obviously it got bigger. The dilation is involved. Okay, dilation by how much? By how much? Let's count this one. 1, 2, 3, 4, 5, 6, 7. The 7 over here becomes becomes, let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 7 became a 14. What have you observed? It doubled the size. Therefore, that's a scale factor of 2. Dilate is scale factor of 2. But if it gets bigger, what happened? Look at my drawing here. So this side will be 1, 2, 3, 2. Let's double it. 1, 2, 3, 2. So C would be here. Yeah. Okay. A to that. So this will be the new letter C. Okay. Because it got bigger, right? The A could still stay there. Now, if you observe, the C is now over somewhat there, right? So C would be somewhat there. So translate 3 units up. 1, 2, 3. Okay, but if my 3 is there, my A would be here. Okay, but look at the final drawing. It's over there. All right, it went to the other side. So what is involved? It involves a reflection. Yes, where? A reflection along this line. 3 units away, 3 units away. Check this out. So you know that's a reflection. So what can you say? Reflect along that orange line. So that goes over there. And then obviously the other coordinate will be over there, right? Good job. Now, figure this out. Answer. Dilate with a scale factor of 2. Okay, the size doubled. But of course, the angles, corresponding angles are preserved. Now, if it doubles, how do I check that? This is 2, 3. Check out y. Y would be 2, 3. 2, 3. Okay. So therefore, times 2, y prime would be 2 times 2 is a 4. And what else? Y prime would be 3 times 2, 6. But is my point at 4, 6? No, that's 4, 2. So meaning if I dilate, my y prime should be here. 4, 6. 4, 6. My y prime should be here. But why is it down there? All right. So after dilating, it got bigger. It also what? It went down over there. So that don't use that yet. The y over 6 will be there. So what will we say? Translate 4 units down. Then it goes down. It got bigger, but the y will be there. The others would follow. And then translate 4 units down. Good job.